So now that we know how to run hypothesis tests for paired data, it's time to look at our old friend, the confidence interval. That's right, we're going to create a confidence interval for the matched pairs data. So if you want to know the average difference between those two samples, between those pairs of data, what would you do? Well, you think that it's in this particular range right here. D bar plus or minus T alpha over 2 times the standard deviation of your differences over the square root of n. Now remember that D bar is the center of that confidence interval, which means it's the point estimate. It's the middle of the interval. It's the average of your sample. And then, of course, we've seen these before. Those are your critical values. In this case, it'd be alpha over 2 because it's a two-tailed picture when you're making a confidence interval. The confidence interval, if you will, takes up the center of the picture, and the tails are on the edges. I have the instructions in here for how to do it, but it's very similar to what we already did in chapter 9 when we were creating a t-interval. It's just that you're using d bar in place of xd and sd in place of the standard deviation. And just a reminder, on your inferential statistics sheet, this particular interval is right here. It's the one for 11.2, so d bar plus or minus t alpha over 2. And then I remind you right here that you're going to use the t-interval to make this one. All right, so let me get back to our notes. There they are. All right, so continuing with our right key therapy data, we're going to construct a 95% confidence interval estimate of the mean difference, mu d, show the formula substitution and result. All right, so if you remember, we have that data set already figured out right here. We figured out L2 minus L1 before. All right, so we have the data set right there, and we're going to show the formula substitution and the result. That's all of our work right here. So we'll start off with the formula. So let me type that up. Oops, I zoomed in a little there too. I was a little zoomed out. Sorry about that. Okay, so d bar plus or minus t alpha over 2 sd over the square root of n. Now I've got to go find d bar and sd. Oh, except we found those a while ago. Let me go back and find those. There, we found those on the same page that we found these right here. So that'll mean d bar was negative 1.923 and 1.605. Now, if you hadn't found them here, you actually can find them when you run the t-interval. Let me show you what I mean. So when you want to do this confidence interval, you go to stat, you go to calculate tests. There we go, tests. And you want to pick number 8, not a test, but a t-interval. Right? That's what it says right on the inferential statistics sheet. Let me pull that up. Right here, it says t-interval, so you use that one. So you grab t-interval, number 8. And then I'm going to go to data because I actually have the data. It's in L3. And then I just want to tell it what my confidence level is. Let me go grab the confidence level. There, it's a 95% on this one. So let me go back and go down here to 0.95. Then I'll hit calculate, enter. There we go. So we have negative 1.923 and 1.605 and 13. See, it gives you all the pieces almost for the whole thing. So this was negative 1.923. And then T alpha over 2, I'll figure that out in a minute. That's going to be the hard part. But the S was 1.605. And then the square root of n is the square root of 13. Now T alpha over 2, we need to go calculate some things real quickly. All right, over here, so let's make a note to ourselves. Alpha is 0.05. That's because our confidence level was 95. Right? Okay, so then we need alpha over 2 because the formula says T alpha over 2. So we want alpha over 2, which is 0.025. And then don't forget that degrees of freedom is n minus 1, which would be 13 minus 1, which would be 12. Okay, so we need these two pieces of information right here. I need to know that it's 0.025, and then I also need to know that it's 12 degrees of freedom, because those two pieces of information will give me my t-score. So t alpha over 2 would be equal to inverse t 0.025 comma 12. Let me grab the calculator. So I go to distribution, pick number 4, inverse t, 0.025. 12. Enter. And I get negative 2.179. All right, so that's what my T alpha over 2 is. So T alpha over 2 is inverse T, which is negative 2.179. And again, it doesn't really matter the negative or the positive. All I really need is the number, right? So if you wanted the positive one, you could do 975. That would work, right? But it's okay if you do 0.025. You just have to know to make it positive for the formula part. All right, so this is what I'm going to use in my formula. So again, I don't care that it's negative or positive. All I care is the number. All I care about is the number, I should say. So let me go in here and I'm going to put 2.179 right here. Oh, on a side note, you could find it with the table as well. Let's see, if I go to the T table, which is this one, I go to the 0.025 column and I go down to 12. There it is, 2.179 right there. All right then. Oop, wrong sheet. There we go. All right, then I want the result. Well, I got that from when I ran the test. Let me do it again. Stat. If I pick number 8, T interval, see it says T interval at the top. I go down to calculate, enter. And it says negative 2.893 comma negative 0.953. There, I have it right there. And that's the answer, so I should probably put it in a little box or something. All right, now what is the point estimate? Well, the point estimate is the center of your interval, which in this case would be D bar. So D bar is our point estimate, which in this case would be negative 1.923, more or less. It's found by taking the D bar right from the data set, or if you had the test already done, the interval already done, you could add up the lower limit plus the upper limit, divide by 2. All right, now what about the margin of error? Well, it's been a while since we've seen that. There, so let me remind you what a picture of this looks like. We have a number line here, and then we have the lower limits over here at negative 2.893, then the middle is at negative 1.923, that's D bar, and then the upper is at negative 0.953. So the margin of error is the distance between that upper limit of negative 0.953 and that middle of negative 1.923. Or if you like, it's half the distance from the upper to the lower. Let me write that up. All right, so I just brought it up here. The error is half the width. You find the width by taking the difference between the upper and the lower limits. So you take negative 0.953 and you minus the negative 2.893. So I put negative 0.953, that's the upper, minus that lower of negative 2.893. So let me grab the calculator and take negative 0.953. Minus a minus means plus, so I really want to add 2.893. And I'll get 1.94. So I want half of 1.94. So let me write that. So this equals a half of negative 0.953 plus 2.893, which is half of 1.94. That's the distance from one end to the other in that interval, which means it is, drum roll, we're going to divide by 2 and get 0.97. That is our 970 even, if you like. That is our margin of error. It's been a while since we saw that calculation. We saw those last in chapter 9. All right, now what does this mean? What does the confidence interval mean? Well, it means we are 95% confident that Reiki touch therapy lowers pain between a value of 0.953 and 2.893. All right, so we are 95% confident that the Reiki touch therapy lowers pain level scores from between about 0.953 and 2.893 for pain sufferers. So it's going to lower their pain scores on a scale of 1 to 10. just to remind you. That's pretty typical of pain levels. They'll say, you get in the doctor's office, say, what's your pain at? 1, 3, 4. So we think it's going to lower their scores from about, lower them about 0.953 to 2.893. So if they were at an 8 before, they could be at like a 7 now. Now, does this confidence interval suggest that there is a significant difference in the pain levels between the two groups? Yes, it does. But we need to explain why. If there wasn't a significant difference, then the null hypothesis would be true. Let me go back to the hypothesis test for this. It's been a while. There we go. So when you have no significant difference, that means that your null hypothesis would be that the mean for the difference would be equal to 0 right here. If after and before are basically the same, then that means that when you subtract them, you get 0, right? Which means that the difference is basically 0. But 0 is not in our confidence interval. If 0 was in our confidence interval, we'd be supporting that null hypothesis. But since 0 is not in our confidence interval, that means that it supports the alternative, that there is a significant difference. So that's going to be a little bit complicated to type up. Let me work on that, and I'll be right back with it all typed up. All right, I said yes. If there was no difference in the pain levels, that would mean that the average pain levels before and after would be about the same. That's what no difference means. And that means that when you subtract them, you would have 0, and that would support the null hypothesis, that when you take the difference, you get about 0. But our confidence interval does not contain 0. If you look at the confidence interval I drew right here, here's 0 way up here, and the entire confidence interval is below 0. That implies that there is a significant difference in the pain levels for the two groups. In other words, that confidence interval appears to be supporting the alternative hypothesis, that the mean difference is not 0. And this idea of containing 0, not containing 0 is going to keep cropping up in this chapter because our null hypothesis is always equal to 0 for the entire chapter. We always assume that the difference between the two groups, whether they are independent or dependent, is 0.